Please open in your learning workbook to page 101. Let's talk about a rule that we learned in the previous math class that allows us to get rid of negative exponents. Consider the following exponential expression, a raised to the negative n power. Sometimes negative exponents are considered undesirable or unsimplified, and it's helpful to know how to get rid of them. One way is to use this rule, which you've seen before. A to the negative n power can be rewritten as 1 over a to the positive n power. We can use this rule to our advantage to discover what would happen if the exponent of our exponential expression was a negative fraction. One of the interesting things about algebra is that if a symbol appears in an equation, you can replace all instances of that symbol in the equation with something new, and generally speaking, it remains true. For example, if we replace this n with a fraction, and this n with the same fraction, we would get a new rule that can be used to help us understand what a negative exponent fraction rule would look like. I'm going to replace the n with the fraction m over n everywhere I see it. This gives me a new rule. When a is raised to the negative m over n power, that can be rewritten as 1 over a to the m over n power, as long as a to the m over n power is a non-zero real number. Okay, let's solve some problems involving this newest concept. Write with positive exponents. Simplify if possible. Use your calculator to check your answer. Okay, here's what we are given in this problem. The base is negative 8 in parentheses, and it's being raised to the exponent negative 2/3. So the first thing we notice about this problem is the exponent is negative, and this rule allows us to get rid of the negative in the exponent. Not the negative in the base, however. That will still be part of our problem. Okay, let's rewrite. So, using this rule, we will rewrite this as 1 over the same base, which is negative 8, raised to the positive version of that same exponent. So instead of negative 2/3, we'll have positive 2/3. Now we can use our previously learned rules to simplify this exponential expression, whose exponent happens to be a fraction. Remember, we had two choices for how to do that, but the second one, the one farthest to the right in the rule, was the easiest. So let's try that one. 1 over the cube root of negative 8, and we'll take that m of 2 and put it on the outside. This makes the problem easier for us to solve. Now we will simplify by following order of operations. We will begin by figuring out what's inside the parentheses, the cube root of negative 8. Well, the cube root of negative 8 is negative 2. So this becomes 1 over negative 2 in parentheses squared. Now we'll apply this exponent of 2. Negative 2 squared is the same thing as negative 2 times negative 2, which is 4. So we get 1 over 4. The answer to this problem is 1/4. Okay, let's do one more problem type. This final learning objective is to use rational exponents to simplify radical expressions. Let's read from the learning workbook together. Now that we know that radicals and rational exponents are related, we can use this relationship to simplify radical expressions. Here's a problem. Use rational exponents to simplify the radical. Assume that all variables represent positive real numbers. And we're given the 9th root of x cubed. Okay, to solve this problem, we want to use one of our previously learned rules, specifically the rule that says this: the nth root of a to the m power can be rewritten as a to the m over n. When we learned this rule originally, this part was on the left side, but it's the same rule. Let's compare. N is 9, a is x, m is 3. So when we rewrite this, it becomes as follows: a, which in this case is x, raised to the m over n, which in this case is 3 over 9. Interestingly, 3/9 is a fraction that can be reduced. The common factor is 3. If you take a 3 out of both top and bottom, you get the reduced fraction 1/3. And then finally, we can put this back into radical notation, remembering this rule. A to the 1 over n is the same thing as the nth root of a. So this is the 3rd root of x, also referred to as the cube root of x. This is our final answer for this problem.